Hello, I'm Kyle with Utility Composites Incorporated. We are the manufacturer of Blackmagic polymer composite staples. A lot of people just know us as the melting plastic staple guys. This is the second video in the Blackmagic Staples University series. If you haven't seen the first video in this series, you might want to watch that one first so that you can find out how your retread facility would benefit from using Blackmagic staples. Blackmagic staples are different than metal staples, and it is important that retread operators understand 5 technical aspects that are vital to ensure success. Having a clear understanding of these critical aspects will ensure that you have a positive experience with Blackmagic staples. In this episode of Blackmagic Staples University, or BMSU for short, I will explain in detail these aspects. Number 1 is staple and tool selection, 2, proper tool technique, 3, proper retread techniques, 4, best staple drive depth, and 5, special techniques for bench splicing. Before I dive into the details of the 5 technical aspects, let me first talk about our nomenclature so that when I refer to specific staples by their part number, you will be able to follow along. We manufacture 5 different staples for retreading. The information in this BMSU series will help you select the best staple for your retreading process. Our most popular staple is the S0537TR. The first letter, S, signifies staple, and since it is the only letter, it signifies fine gauge or 19 gauge staples. The 05 signifies the size of the crown without the decimal. In this case, it's a 1/2 inch crown. And the 37 indicates the length of the staple leg in hundredths of an inch. This staple has 3/8 of an inch legs, or 0.375. We just shorten that to 37. And finally, the TR represents that the staple is made for tire retread. In case you don't know, we also manufacture plastic nails and staples called Raptor for woodworking and composites applications. The Raptor staples are identical in sizes and product numbers, but are made from very different composite materials. The TR suffix on Blackmagic products helps to distinguish which staples are made for retreaders and which staples are made for woodworkers. In the Blackmagic product line, there are 4 other staples that all begin with SH, which in our nomenclature indicates heavy gauge or 16 gauge staples. The crown size is next, either 0.5 or 0.4, written as 05 or 04, followed by the leg length in hundredths of an inch, such as 37 for 3/8, 40 for 7/16, and 55 for 9/16. Finally, all tire retread staples have the TR designation at or near the end of the product number. The next question I always get is, which one of the 5 different Blackmagic staples should I use at my facility? Let's try to answer that question. Blackmagic staples come in 2 formulations, standard and low melt. Our standard Blackmagic staples drive slightly better, and our low melt staples are best for cure temperatures below about 215 degrees Fahrenheit. This chart shows which products are in the standard and low melt formulations. To select which staples are best for your process, first determine if you need a low melt staple for lower curing temperatures. If so, either the SH0537TR or the SH0440TR-LM will work. The SH0537TR has a wider crown for easier placement on the splice, and the SH0440TR-LM has slightly longer legs for better holding. If your cure cycle is at a higher temperature, you should use the SO537TR since it is best for most retread applications. If SO537TR staple breakage and high durometer rubber is an issue, then use the heavy gauge SH0555TR or SH0440TR staples. Now that you understand our nomenclature and how to select the right fastener for your process, let's get back to the 5 critical components to ensure success with Blackmagic staples, starting with tool selection. People often ask me, do I need to use your tool? In short, the answer is yes. Here are the reasons. First, Blackmagic staples are thicker than metal staples, so they will not fit in tools made from metal staples. Additionally, Blackmagic staples need tight lateral support during driving. The drive chamber must be tight so the staple cannot shift left or right. When the drive chamber has too much wiggle room, staples can get slightly off angle, leaving room for the staples to flex, which could cause breakage. The result is poor drivability. It is important to note that due to the tight drive chamber in the tools designed for Blackmagic staples, you cannot use metal staples in these tools without risk of damage. So, what brand of tools must be used? We are proud to have Omer SPA out of Italy as our exclusive pneumatic tool manufacturer. I bet many of you are already familiar with Omer tools, as I have seen them in use with metal staples at many retreading facilities worldwide. For those of you that are not familiar with Omer tools, they are considered to be top-tier industrial grade tools that are competitive in price with other high-quality pneumatic tools. Omer tools are extremely fast, lightweight, well-balanced, and rugged. Omer manufactures tools for metal fasteners, but they also manufacture tools exclusively for us that have been designed to properly fire Blackmagic staples. If your facility uses Omer tools with metal staples, unfortunately, those tools will not work with Blackmagic staples. Even though they're manufactured by Omer, they are still very different than Omer's line of tools that have been specifically engineered to fire Blackmagic staples. Now, let's talk about the staples. The original Blackmagic staple, and still our most popular retread staple, is the S0537TR. As you learned earlier, this staple is 19 gauge with a 1/2 inch crown and 3/8 of an inch legs. This staple works very well for facilities that have a cure cycle temperature greater than about 215 degrees Fahrenheit or about 102 degrees Celsius. The pneumatic tool that fires the S0537TR staple is the Omer 81P. The Omer 81P comes in 4 options: trigger safety with a regular size magazine, nose safety with a regular size magazine, trigger safety with a long magazine, and nose safety with a long magazine. Next, we have the SH0555TR staple. It's a 16 gauge staple with a 1/2 inch crown and 9/16 of an inch legs. This staple also works very well for facilities that have a cure cycle temperature greater than about 215 degrees Fahrenheit or 102 degrees Celsius. The pneumatic tool that fires the SH0555TR staple is called the Omer 82P. The Omer 82P comes in the same 4 options as the 81P. The SH0537TR is a 16 gauge staple with a 1/2 inch crown and 3/8 of an inch legs. Unlike the first 2 staples, this staple works very well for facilities that have a cure cycle temperature less than about 215 degrees Fahrenheit or 102 degrees Celsius. We call this staple a low melt staple because it softens and flattens at lower temperatures. The stapler for the SH0537TR staples is the Omer 82P. The final staple size in the current Blackmagic product line is the SH0440TR and the SH0440TR-LM. This is the newest staple that we have introduced to retreaders in response to some facilities asking us to make a staple with a slightly stiffer crown and with legs closer to a 1/2 inch. This staple is also 16 gauge like the previous 2 staples with approximately a 7/16 of an inch crown and 7/16 of an inch legs. This staple is available in standard and low melt formulations. The SH0440TR and SH0440TR-LM staples are driven using the Omer 83P stapler. The Omer 83P comes in 2 options: trigger safety with a regular size magazine or nose safety with a regular size magazine. Now that we have the tool and staple selection behind us, let's talk about proper tool technique. The biggest challenge in converting a retreader to Blackmagic staples is ensuring that the operator uses a slower pace while learning the proper technique. I've been in enough retread facilities to understand that the word slow is not in an operator's vocabulary. Trust me, I know that the name of the game is speed. We only need the operator to slow down temporarily until they master proper technique. Once the technique is mastered, which usually happens within 2 or 3 tires, then it is easy to speed back up to the normal pace of operation. We just need to slightly alter the operator's muscle memory. So the original question still lingers: what is the proper technique? Well, the operator must use firm pressure and must position the nose of the tool evenly so that when the trigger is pulled, the staple enters the rubber directly and evenly on the tread lug. If the nose is improperly positioned, one staple leg may hang over into a gap. In this case, the staple has nothing to hold and further breakage may occur. The operator must also ensure that the tool isn't at an angle that would leave one end of the nose higher than the other end, which would also result in unnecessary stress on the corners of the staples and possible staple breakage. With steady and consistent movement, along with deliberate placement, the operator can pull the trigger and expect the same penetration and holding results as you would with a metal staple. Now that we know what the proper tool technique is to prevent breakage, let's talk about best practices for retreading that go hand in hand with Blackmagic staples. There are 2 usual culprits that can cause poor performance of Blackmagic staples. 1, cushion gum on the splice sticking up too high, or 2, cutting the tread too short. For best results, the cushion at the splice must not stick up more than about 3/16 of an inch, and the tread must not be cut short by more than 1/8 of an inch. The tread can certainly be cut longer, but any shorter than 1/8 of an inch will put unnecessary strain on the staples, which might cause breakage. As you know, these are best practices for retreading, whether you're using metal staples or Blackmagic staples, but their importance is magnified when using Blackmagic staples. Now let's talk about how deep the staple should be driven. Blackmagic staples should be driven so that the bottom of the crown is flush with the tread surface. With the correct staple penetration, you should see the staple crown sitting on top of the tire tread surface, which will ensure proper holding power. If the air pressure is too high and you see staples driven below the surface of the tire tread, you may experience breakage and holding failures. And finally, as you all know, there is a wide variety of retread building machines, and each of those machines vary in the force or stress they put on bench splices. Some common machines that I have seen can create a burst of tension on bench splices when the motion of pulling the tread onto the casing starts. With metal staples, the burst of pressure might or might not be a problem, but with Blackmagic staples, you might need to pay a little more attention during this phase. If your machine operates in this way, then your operators may need to assist the bench splice by hand during the startup of the tread movement to reduce tension on the splice from the initial burst of movement. Believe it or not, I have personally shown this simple trick to many facilities worldwide, and it has made the difference from failure to success. In this Blackmagic Staples University video, I have explained the important technical aspects that you must know about Blackmagic staples in order to ensure success: staple and tool selection, proper tool technique, proper retread practices, staple drive depths, and tips for assisting bench splices. For questions regarding Blackmagic staples, please contact us or your local distributor using the information on the next screen. We are always happy to hear directly from you. Thank you for tuning into this edition of Blackmagic Staples University. I hope to see you again on the next edition of this series, and always remember, if a larger bottom line is what you desire, use Blackmagic staples in your tire.